Commander King here with this wonderful plant, and we're here to talk about the mole, right? So the mole is a super important unit in chemistry because atoms are so hard to count in terms of there are so many of them. So in this pen, or even in the point of this pen, there are billions upon billions upon billions of atoms, whatever this pen is made of. And so it would be very ineffective to say, we have 1.6794732.66 times 10 to the whatever atoms of this all the time. So instead we use the mole, which, if we recall, 1 mole is just 6.02 times 10 to the 23rd of anything. So I could talk about a mole of pencils, but I wouldn't want to because who has that many pencils, or who would want that many pencils? Okay, so generally it's only used with atoms. And the mole can be used to get to a lot of different units in chemistry. So I can use the mole to, if I have 1 mole of sodium, I could say, well, how many sodiums is that? Well, that's 6.02 times 10 to the 23rd atoms of sodium per 1 mole. So that's how I get to the representative particles. It could also be molecules. If I have H2O, I could have 6.02 times 10 to the 23rd H2O molecules per 1 mole. Okay, and the mole at STP, at standard temperature and pressure, a mole of a gas generally takes up 22.4 liters. So there are 22.4 liters in a mole of a specific compound or atom. And finally, the mole, unfortunately, atoms are so small we can't count them. So generally, instead, what we do is we measure their mass and then use the mass to figure out how many we have. And that's through something called the molar mass. And the molar mass we find on the periodic table. Okay, so that's that. All right, so let's just take, for example, that I assume I have 1 mole of NaCl. So let's pretend I've got 1 mole of NaCl. And I want to know 1 mole of NaCl, how many molecules that is. Okay, how many molecules of NaCl that is. So I'm starting with 1 mole, and I'm just going to do a few conversions using this nice diagram here. In 1 mole of NaCl, and I'm trying to get to molecules of NaCl. Okay, in 1 mole of NaCl, well, I don't know how to get there, but I'm thinking about it. I want to cancel the moles of NaCl. I'm trying to get to molecules of NaCl. And I know in 1 mole of NaCl, I have 6.02 times 10 to the 23rd representative particles, which in this case is NaCl. So I have 6.02 times 10 to the 23rd molecules. Okay, so if I multiply that across, well, that's just 6.02 times 10 to the 23rd molecules of NaCl. So that's how many molecules I have. Now, if I want to get to atoms, well, I notice in this molecule of NaCl, I have 2. So I could multiply this by, in 1 molecule of NaCl, I have 2 atoms. Okay, and then just double that, and that would be 1.204 times 10 to the 24th atoms. All right. Now let's think about something else. What if I want to know, hey, how much does 1 mole of NaCl weigh? Well, again, I'm going to start with 1 mole of NaCl. I start here, and I see, okay, I've got to get to the mass, so I've got to use the molar mass. So I'm trying to get to, again, grams of NaCl. Okay, and I know to get here, I want to cancel my moles of NaCl, and I need to know how many grams of NaCl are in a mole. So I'm thinking, okay, how do I know how many grams? Well, that's when I need to look back at the periodic table. And if I do, I see Na here, and I see, this 22.99, that tells me how many grams of Na are in 1 mole of Na. Yeah, but I also need to think about, well, wait a minute, this is not just Na, it's NaCl, so I need to pull up that for Cl too, and so it's 35.453. So in 1 mole of Na, I've got 22.99 grams. In 1 mole of Cl, I've got 35.453 grams. Well, then in 1 mole of NaCl, I would have 22.99 plus 35.453 grams of chlorine. So that gives me a total of 58.443 grams of NaCl. So this number again came from adding these two together because I had NaCl, and that would 1 times 58.443 is just 58.443 grams of NaCl. So that's how much I would weigh out on my scale if I needed 1 mole of NaCl. Okay, now here's where it gets a little bit ridiculous because NaCl we know is a solid at room temperature, but let's say hypothetically something went crazy and somehow we got NaCl to be a gas, we heated it up and it became a gas, then it wouldn't be at standard temperature. But let's just assume that we have somehow NaCl, there's a special condition, maybe by changing the pressure, where NaCl became a gas and we had 1 mole of NaCl. And we want to think about, okay, well, how many liters of NaCl does that take up? How many liters of space does that take up? Well, I'm looking here and I need to go to my volume of gas, and I know I'm 1 mole of NaCl. I want to cancel that, so I'm going to put my moles of NaCl on the bottom. I'm trying to get to liters of NaCl, so I'm going to put that on top. And I see my conversion here. In every 1 mole, there are 22.4 liters. So in 1 mole, there are 22.4 liters. And I know now, 1 times 22.4 divided by 1, that there are 22.4 liters of NaCl in 1 mole of NaCl. Okay, so these conversions are going to be super important when we try to figure out other things, especially when we're trying to calculate reactions and figure out how much of each thing we need. All right, well, hope this was helpful. For Pea Shooter and I, Commander King, out.